Okay, so we're going to get started right away. Let me share my screen. How was the assignment? There was an assignment for last class. I don't know how many persons were able to try their hands on it over the weekend. If you were, you could there's a place where you can submit your assignment. You can submit to a Google Sheet so that we can also review it at our hand. All right. I'm trying to get what we have for today on. Okay. Okay, so like we usually do, we're going to our training for 30 minutes. Then we'll be having a break, a quiz break for 5 minutes. I'll train for 30 minutes. Another quiz break for 5 minutes and train for 30 minutes, quiz break for 5 minutes. Then we'll have an open forum at the end. So if you have questions, please put your questions together so that we can ask the question at the time. Okay, so today we'll be doing NumPy. And NumPy is another very interesting topic because it's going to be used for people that are interested in deep learning, and maybe you want to work with image data, voice data, and some data sets like that. You need NumPy. You need a very, very good expertise on using NumPy. So it's good to pay attention to it. You'd also use it with text data as well. It's very good for numerical computation with Python. So that's what we'll be looking at today. And we'll be taking you through the basics of NumPy and every other details regarding that. Okay. I think I'm having some persons at the lobby and trying to get them admitted. Okay, let's jump into what we have to do right away. So we have on our notebook, on the LMS, we have week 2 starting on week 2, right? Started on Saturday. So that was just to give you like a basic introduction on what we're going to be doing this week, and so that you can have time to read it ahead. So we'll be looking at NumPy Basics. We'll be looking at NumPy Basics. We'll be looking at Okay, so we'll be looking at NumPy Ndarrays, function and indexing. Then we'd also be looking at operations using NumPy operations, basic statistics and operations. So that's what we'll be looking at today. And if we have time, we'd work on some exercises together. Okay, so let's just jump into what we have for today. So we'll be starting off with NumPy Basics. And like I mentioned during the last class, we have the packages, and I was trying to introduce packages to everyone. And I explained that if you have to write your code, everything lumped up in a single Python notebook or a single Python file is going to be very, very messy. Your code base will be very, very messy. And that's why you have your functions and your methods. The functions and methods are very, very powerful. And it allows for code reusability. People can always reuse what other people have written. If you've written a function, someone else can call the function and use this function. However, packages are a directory of Python scripts and each script is called the module. I mentioned it during the last class. And within that module, you can have functions, methods, and different types. And in Python, we have several packages for different functions. We have packages for data science, such as NumPy. NumPy is one of the packages for data science. And so because this is a Python for data science class, we'll be focusing more on packages for data science. So Python is a very robust language. Can you all see my screen? Somebody said you can't see my screen. Can you see my screen? If you can see my screen, just give me a thumbs up so that I can can you see my screen? I am just getting one person saying he can't see my screen. Can we all see my screen? I need a response. You can drop a message via chat. I know we cannot talk. If you have if you can drop a message via chat, please do. Can you see my screen? All right, great. Thank you. I just need to confirm that so that we are all on the same page and we get to continue. All right. So I was explaining that, okay, regarding the assignments, when doing the open forum, I'll show you the ones I was referring to so that we don't eat into the time we have for today. Okay. Okay, so I was explaining a packages, the directory of Python scripts, and each script is called a module. And I was saying that we have several packages in data science. In Python. Python has a lot of package. It's not just for data science. You can use Python for full stack web development. And what I mean by that, you can use it to build a full-blown software application. I think LinkedIn and which other, I think was it Instagram, was written with Python. So you can use Python to write a full-blown web application, but then Python is widely used in machine learning and data science because there are several packages that support data science and machine learning problems. And so you find out that a lot of people tilt towards Python. There are several other data science languages that you can use in data science. Some people use R, some people use MATLAB, and so many other data science tools. But you find out that a lot of people tilt towards Python because once you know Python, it's easy to pivot to. You can easily integrate it into web environment or software environment. And so you find out that a lot of people tilt towards Python. So for this course, we'll be focusing more on the data science packages in Python. And so we are going to be looking at pandas and NumPy. So this class will be focusing on NumPy. NumPy is it's a numerical Python package. It's a numerical Python package, and it's used for it helps you efficiently work with arrays. So I'll be explaining what this mean because of people that are beginners or maybe that they don't really have a mathematics or computer science background. All right, so we have other packages like matplotlib for data visualization. We have Seaborn for data visualization. We have scikit-learn for machine learning. So all those packages, they have their specific use cases. They have what you can use them for. We have Keras also for deep learning. We have Pandas for data manipulation as well. So all of these packages are very great packages that you can easily use. And when you get to know them, it's easy to use them for your task, for different tasks, different types. You find out that these packages are very, very powerful. Like, I hope we can get to it. You see how we can convert numbers into pictures using NumPy. NumPy is that powerful. You know, when you start working on image image classification or image recognition systems, right? You might be working with TensorFlow and PyTorch. You might be talking about tensors and all of that. But for NumPy is very powerful that it can help you with some image modification. Maybe you want to do some conversion or manipulation on your images. NumPy can do that as well. So if you know some of these building blocks, so like we did last week, last week, what we did basically last week was just to get us introduced to Python, Python syntax, the building blocks of Python. We talked about variables, data types, data structures, functions, methods, and all of those that we learned last week. They are for us, they are building blocks that would help us with our data manipulation or the use of Python when we are working in data science. And even basically you can use it to build basic software application as well. Okay, so I'm going to go right into what we have for today because of our time. All right. Okay, so NumPy, like I mentioned earlier, NumPy is one of the libraries in Python that's used to perform numerical operations for data science. So, we've talked about lists, dictionaries, but they have their own limitation when it comes to manipulating mathematical operations. You find out that there are some operations you cannot do on lists. You have to convert them into arrays. So before I get into arrays, right, I want to go into the basics of NumPy. So before you use any package, just like I explained last week class, before you use any Python package, you have to install it if you don't have it installed on your system. And explain the installation process. So you can go back to the video of last class. If you missed it, you can go back to the video and watch the how to install this. It's very simple. You just go to your Anaconda prompt and just type pip install NumPy. Pip install NumPy. But usually if you've installed Anaconda, it comes automatically installed. You might not have to install it. But for you to know if it's installed or not, if you run this import NumPy as MP and it shows an error, and if it says NumPy module not found, that means it's not installed. So you have to go to your Anaconda prompt where you launched, maybe you just launch a new Anaconda window environment, then you just write pip install NumPy, and then it starts downloading all the dependencies and all of that. Then once it finished installing, it tells you that it has finished, it has successfully installed, and you can now reload this cell and it brings up it tells you that it doesn't show any error anymore. So after installing your NumPy, you can now use it. And I explained that there are different ways of installing your packages. You can either import the whole package, like your import statement, then the package name, in this case is NumPy. Then you can use your alias as MP, that is you are giving it like an acronym, a short name, such that anytime you want to refer to NumPy, you can always, instead of you writing NumPy, you can just use MP for short. So this is almost everywhere. This is a standard way of importing NumPy. So you can just say import NumPy as MP. And what it does is it imports all the dependencies, all the modules, the functions inside NumPy has been imported into this notebook. So you can use any one. So array is one of the functions inside NumPy. And I'll be explaining to you the difference between a list and an array very quickly. Sorry, I'm trying to check the lobby as well. Okay, so after installing your NumPy, you can now use the NumPy, NumPy in your notebook. So after the installation, for example, now if in using the NumPy, any of the function inside NumPy, array is one of the function. I'll be introducing to other functions as we proceed, but I just want you to understand, why do we need NumPy? What is the basis of NumPy? Why not we stick to other data structures that we've learned before? What is the importance of NumPy? So I'll be explaining that very quickly. So after importing NumPy, in the usage, you can, for example, if you want to use a function called array, you can, because you've already imported the old NumPy package, you can just say np.array and use that function. So the other way of importing, that's the first way of importing your NumPy. There's another way of importing NumPy. Sometimes you might not want to, maybe you're working on several other projects and you just want to use only one of the modules of a Python package. You want to just use array. Array is one of the modules of NumPy package. If you just want to use array, you can easily install and import NumPy using this is the second way of importing NumPy. Now, okay, if I have not imported NumPy in full, right? And I just say array, let me just do this. Array is going to throw an error because I have to reference np.array to use this model. But if I import NumPy in this way, like I just import only NumPy, only array, from NumPy import array, I'm just importing only the array model from the NumPy package. So this way, I'm not importing the full NumPy package. I just want to use array. So in this case, in this way, the array example is going to work. So if you use it this way, you find out that, sorry, I need to put a comment here. All right, the array normally takes a list. So if I load this array function, you find out that you see that this it's now recognizing it as an array function. So, but usually, most times you just stick to this way of importing NumPy because that's more easy and you don't get to run into several errors when you use this method. So just know that when you want to use a NumPy package, just to import NumPy as np, and then you can always reference any of the methods using np dot the method name. All right, having understood that, now let us look at the usage of this NumPy package. Typically, we all know a list, right? A list is what a list, we have different elements within a list. It can hold different objects, whether an integer, floating point number, a string, or other list itself. So you're given a list called my list. Now, if you want to, for example, you want to perform an arithmetic operation on this list, like you want to multiply every element in this list by 2. If you just do your mathematical operation, my list times 2, what this does is going to duplicate that list. It's not going to perform that arithmetic operation. So you can see that this is the limitation when it comes to arithmetic operations. You can't perform arithmetic operations using lists. So, and then because you're doing data science, data science involves a lot of computation. You're going to do a lot of computation when doing data science related tasks. So you need something that can actually do computations really, really fast. And arrays are very, very good when it comes to computations. So and that's why we are having to use arrays. So let me give you an example. So if I had to do my list times 2, it's going to duplicate the list. It's not going to give you the answer. So that is why we need array. If we now have to convert this list into an array, we can actually do our computations easily and very, very fast. So let's convert it into array. Now that's where we need a NumPy module. That's where we need that NumPy module that we've imported. You can just say np.array in bracket, this is the function that we are going to use for NumPy. I want to convert this list to array. So to convert it to an array, you can just say np.array, then the name of the list, my lists. And this automatically converts this list into array. Because I'm going to still use this array, let me just name it X or something. Let me just give it a name so that I can always reference it when I need it. All right, so you can see that this list has been converted into an array. So now, because it has been converted into an array, let's do our arithmetic operation now. Let's just say X. Now, we want to multiply every element in this list now into, we want to multiply it by 2. So you can easily, the name of the array is called X. You can just say X times 2. And you can see that, sorry, smallest X times 2. You can see that the numbers have been multiplied by 2. So that is the difference between a list and an array. A list there's a limit to what a list can do. A list cannot do, maybe you want to perform a multiplication, division, addition, and all of that. A list would not do that. Let's do a division with this list. You find out that it's giving you an error. Let me reload this. It's saying unsupported operands for lists. You can't use this with a list. If you want to add 2, you find out that your list can't do that, but you can do anything with your array because you have your array now. This is your array, right? You can easily say X plus 2, and then it gives you your result. You can see that your result is now, it has added 2 to all the elements in this array. So I believe we understand the difference between the list and the array. All right. So having understood it, these are other, you can do any, it can even perform all this, all the complex arithmetic operation. You can use arrays for that. So now, without arrays, how would we have solved this problem of adding a number adding 2 to this list? How would they have solved this problem if we never had array, if nobody had actually come up with a function called array? We would have written a Python function to perform that operation. Remember our functions, right? Yeah, so you could have written a Python function to perform that function. Okay, you are having issues with installing NumPy. Okay, we'll look at that during the open forum. So that we can let's just run through what we have now because of our time. All right, so now let's try to manipulate this list, and without arrays, let's try and write a function. So you could have said def you could just say maybe multiply or something, or multi. It's going to take my list. Then you can now say that's my list. Or it might not be a function. You could just write a for loop rather. We might not have to write a function because we could just do a for loop instead of a function. For every element in my list, multiply that element by 2. Right? And print the answer. Let's just say y is equals to, and print y. So if you would have written this function, right, without an array. So, but you can't be doing all of that for very, very large, complex manipulation. That would take a lot of, effort. So that's why everybody tilts towards using NumPy. So let us move forward in our explanation, this explanation. Okay, so I've explained this, importing NumPy as alias. If you had, anytime you want to use NumPy, you don't have to write the full NumPy. You can just use your alias to refer to your NumPy. So I've also explained how to convert a list into array. You could just say np.array, then the name of the list. It converts it into an array. All right. Now we have different dimensions of array. So we'll be going into before we go into dimensions, let me just follow this notebook. Right. So we have still on the way, still on manipulating your arrays and your list and arrays. So we can create, let me just touch on dimensions a bit because of what I'm going to be explaining. So this that you're looking at now is just a dimension of the array, that is an array with just one single row. Think of a dimension as rows, right? Rows and columns. So this is an array with just a single row. So it's just the one-dimensional array. So if you want to check the dimension, you could just say the name of the array, x. Let me just x.shape. Shape is a function in Python. So it tells you that this array has four columns and just one row. All right, so it's a one-dimensional array. Okay, so having this, right, you can create more than one dimension. You can create 2 dimensions, you can create 3 dimensions. But let me go right, because I'm just going to talk about dimension. Let me go right into why NumPy. Why do we have NumPy? Why do we need to use NumPy? So I talked about that lists are very powerful. They all different data types, and you can update, remove, and you can do several manipulations when it comes to lists. But then in data science, we need to perform mathematical operations over an entire collection of values very, very fast. And you don't have to start writing functions. For example, you want to calculate a BMI, the body mass index of a particular set of people. Maybe their heights, like 3 people, their heights are these and their weights are these. With a list, you have to do all of this calculation with a list. So, but instead of you doing all of this calculation with a list, you could easily convert them into arrays and calculate the BMI. So what you're doing here with the list is that you're taking each of the heights and the weights at location 0 divided by the heights at location 0 and raised to power 2. For the first person, you're doing the same thing for the second, for the third, for the fourth, for the second and first, second, and third person, then after you have all your results together. So that is not sustainable. What if you have 1 million people and you need to calculate their BMIs? Are you going to be doing all of that for them? So that is why we need our arrays. Arrays are very powerful. They can just help you calculate all your computations at a very, very fast rate. Okay, so let's see how we can use arrays to do that same BMI, calculation. Let's see how we can use arrays to do that. Now, using arrays, you can easily convert each of this, the height and the weight. Now, you can take the height. This is an height. How do you convert it to an array? You could just do np.array height, converts it into a NumPy array, and then convert all the weights. Even if it's 1 million, you convert all the weights into arrays, and then you just do your computation of BMI. Your BMI is what? The weight divided by height raised to power 2. And when you do your BMI computation, you get your results. So I believe you understand why NumPy is actually good and better off when it comes to mathematical operations compared to lists. Okay, so now we'll just go right into the different dimensions of the NumPy arrays, and then we can proceed from there. So like I mentioned, okay, before the dimensions, let's look at some of the operations we can do on NumPy. So NumPy can do element-wise calculations, just like lists. In lists, in lists, we can do element-wise selection. Like they have different, there are different locations. The same thing, you have the same thing in NumPy as well. So for NumPy can do calculations. So you have an array, like an array can add two arrays together, which you've seen before now. You can do subtractions and other calculations as well. You can do divisions and all. So let's go into the basic statistics of NumPy and operations. Okay. If you have questions, please, you can drop your questions via chat. We'll attend to that during the open forum. Okay. All right. So for the statistics and operations, just like we did during the variables, operations, and data types when we're doing Python, it's the same thing. It's the same symbol, right? But now you're just going to be thinking of your manipulation in arrays now compared to using your normal lists and your normal addition and subtraction. All right. So when we import NumPy, normally for every usage of NumPy, you have to import NumPy. If you're starting off with a new notebook, you have to import NumPy. So there is a function called a range function. So I'll be showing you also NumPy functions. After Ndarrays and functions, I'll be showing you some of the NumPy functions as well. We have the range function. What a range function does is that it gives you natural numbers starting from 0 to the end -1. That is, if you want a range of values between 0 and 9, you just say np.arange bracket 0, 10. That is, the last number is not inclusive. So it's going to create an array of natural numbers from 0 to 9. So if you want other range of values, probably you want ranges of values from 5 to 9, you can make your starting point 5, and then it gives you a range. Sorry, I see that you have to import, you have to import NumPy before you use it. I forgot to run the first cells, so that's why I'm running into an error. So now, because you're asking for a range of values between 5 to 9, so you have 5, 6, 7, 8, 9. But I want a range of values between 0 to 9. So I can just do 0 to 9. All right. So now we can perform other manipulations with this arrange. You can create more range of values and do, okay, you have an array. Now this is an array called, the range of value is called ARR, right? ARR, you can add ARR to ARR. That's the addition operation. ARR plus ARR will give you can see that this is added together and it's giving you the addition. You could also have the multiplication as well. You're multiplying each of the elements in this array, you're multiplying by each other, and then like taking the square and you're having your answer. You can also do minus subtraction. When you subtract the two array, of course, it's going to give you an array of zeros. You can do division too. So when you do division, it will give you the value of this result. You could do any other manipulation, just like you use your normal operations in when we're starting off. You can also use your division. You could use your power. You could use all the operations that but now this time around you're dealing with arrays. All right. So we also have some array functions, common array functions. Okay, I don't want to mention this here because let me touch on it. I'm going to talk about some of these functions extensively when we talk about dimensions and then the functions. But then there are some other functions. Instead of saying x plus y, like giving an array x and y, instead of adding the two arrays together, you can call a NumPy function called add, and this adds the elements x and the array x and y. This is the first array. This is x. Let me run it from the beginning. Okay. This is X and X, Y, Z. So you can have array, you can have, instead of you saying X plus Y, right? X plus Y will give you this. Instead of you saying X plus Y, you could easily say that np.add X comma Y to give you the same answer. So that's another array function. I mean, NumPy function in add is a function in NumPy that you can call. Instead of saying minus, you can do subtraction as well. If instead of saying instead of saying multiplication times using your symbol time, you can do np.multiply and it multiplies the arrays together. All right. And those are some of the functions we have in arrays. All right. You can also do your dots, your square root. So your dot operation, what it does is, now, let me show you what the multiply does. When you are adding, right? This is the X. This is, let me print out the X and the Y so that you see what we're talking about. This is X and this is what? Y. So your addition does, it picks the first element in the first row and adds it up with the first element in the second, in Y. The second element here, it adds it up with this. The third element adds it up with this. That's how it does this operation. It does element wise calculation. So every element in the same location, it adds them together. So that's what an array does. That's how it does its calculation. For people that have background in mathematics and computer science, you must have done this under linear algebra. So it does element-wise calculation, but you might not really, for now, right? Because you're starting off, you might not really focus on all these details and technicalities. But later, if you want to really, really go in depth, you might just have to, you will have to learn some of this basic mathematics just to know how they work. But for now, you could just know that as it performs elements-wise operations, that is if it's calculating X plus Y, it picks the elements in X and Y location and adds them together. This is location A11 or X11 and Y11. It adds it up together. X12 and Y12, it adds up. I'll explain to you by what I mean by X12 and Y12 when we're talking about indexing. All right. So I just want to pick that out so that you understand how it works. The same thing goes for addition and subtraction. All right. Okay, so let us go and to okay, square root as well. You could do a square root and a dot. NP dot square root of 981 will give you what? 9. NP dot square root of any number would give you the square root of the number. So you can, it has several, there's so many operations that you can use in an array. All right, so let's just go into the ND arrays. Okay, just a minute. Okay, before then, I want us to let's do a short quiz. And let me see, let's do a short quiz before we go into the ND arrays. It's like some people are having issues with network. They're having to go in and out. So I'm going to share a Slido. I'm going to share a Slido link so that you can all join. Let me see if it's loading. Just a minute. Okay. I would like to, okay, we'll take the quiz at the end because of our time. I mean, because of the context of the quiz, the kind of questions. But let's just do let's just do some kind of poll. We want to gauge your level of understanding. I'm sure that you've been learning and on your own and all of that. One thing we do in Data Gen Z, we like feedback and we want to continually improve on our our content rather, and our delivery. So we want to find out how well you're able to understand the concepts, and how well we can also support your learning. Okay, so let us just take this short poll. You can, I just posted the link here. For Model 1. You can interact with the poll now. Let me share my screen so that you can all see what you'd like. Okay, we have just few more minutes. Like we have 1 more minute to do this. You want to take more inputs? What's your level of understanding of the introduction to Python module after week 1 classes? Want to know how much you understand what the class in class explanations and the contents on the LMS. Okay. We're going to stop this so that there's another one more. There's one more we want to take, one more poll. Okay, I think we'll stop this now because of our time, 8:45. Thank you all. But there's another poll about the contents. Rate the content, the structures content delivery, and I just shared it now. I want to share the link. I don't know if you're able to access the link. Please want your honest feedback. Let me share the link. I think it's the same link. Yeah, it's the same link. You can use the same link. The poll is active now. They have like 1 minute more, 1 minute more for that, so that we can go into another thing. Okay, we'll be stopping it right now because of our time, so that we can go into what we have. Thank you all so much for that, your time. Thank you. So let's go right into what the next thing we have before we take our last quiz, and then we'll have questions. Okay. Let me share my screen. Okay, so we'll be looking at the NumPy array functions and subsetting. Okay. All right, yeah. So like I mentioned earlier, we have NumPy as the ability of, performing arithmetic operations easily and very, very fast. And there are some functions that are in NumPy that you can use to perform some of these operations. Okay, so the first thing we're going to do when we have a new notebook and want to use NumPy is to import NumPy as NP. And here, what we want to do now is we want to create two arrays, two NumPy arrays. The first one is array X, that's this array. And if you want to create a NumPy array, you use the array function in NumPy, np.array, enclosed in a list. So this is one dimension. We're looking at other dimensions in this notebook as well. So after doing that, you can define another array called y, np.array 9 and 10. So when you do this, you can easily check the shape of this array using the name of the array dot shape. It gives you the first one says is 5. We have 5 elements in this array. It's a one-dimensional array, and then this one has 2 elements in the array. Okay, so I haven't done that. Sorry, I'm having to navigate through some of the. You can convert. What if you want to create a 2-dimensional array? So if your 2-dimensional array is just like you having your more than one row in your table. So you think of this array as, let me load this as a list of lists, like you have another list enclosed inside a bigger list. So this is the first list, right? This is the second list. And here you have 2 lists inside enclosed into a bigger list. So when you create an array using this list, it's going to give you a 2-dimensional array. So think of this first list as this first list as the row. Those are the rows, and these are the columns. So this is like a 2 by 2 array. That is, it has 2 rows and 2 columns. So array is defined n by n, that is rows by columns. So you have 2 rows and 2 columns in this 2D array. You could have more than one array. You could have a multi-dimensional array, that is an array in a 3-dimension or 4-dimension or 5-dimension. So you could have, this is a 3-dimensional array. So here, when you're talking about, when you're looking at, when you're working with images, most of them are like, they're in 3 dimensions. They are not no more, they're no more in 2D. 2D is more of the tables, your tables, that your tabular data, they are 2 dimensions. But when you're working with maybe images and all of that, you're already in 3 dimensions. So this is how 3 dimensions is. A 3-dimensional array is like a list inside another list inside another list. So if you look at the inner list, you can see 1, 2, 3, right? This is this 1, 2, 3 enclosed inside a bigger list, right? And this bigger list is enclosed inside another bigger list. That's the one the one covering all of this, right? So this is a 3-dimensional array. So I want I'll be explaining most in this class. We're working with 2 dimensions for our calculations and all of that. Well, that's what we'll be focusing on for our calculations, working with 2-dimensional arrays. But this is just for you to know that there are other dimensions. You could have 4 dimensions and more than 3-dimensional arrays. So here, you think of these arrays as, this is 1, 2, 3. This is the first array, list inside another list. This is another list. This is another one, and this is another one. And so when you printing it makes you see it better. So you can see this is the first one, this is the second one. See, all of these are enclosed inside this bigger list, and then we have the final bigger list. I believe you don't worry if you don't understand this, but as you progress, you understand it, right? But we'll be focusing more on the 2 dimensions for this class. So we have different functions in NumPy. They are inbuilt functions, and I explained what a function is in our previous class, right? So all of these functions, they've been written to perform some specific operation, at which I'll be explaining to you what these functions mean and what their use cases. So the first function we're talking about is a range. A range is different from range. You know, I mentioned range. Range gives you a range of value between 0 and the last number not inclusive, right? But this is NumPy, np.arrange. An np.arrange is also similar to range. This gives you an array of values. So given this list, right, let's create an array of this list. That we use np.array har. It converts this list into an array 1, 2, 3, 4, 5. All right, that is a basic way of creating an array. If I say create an array of 10 numbers from 0 to 9. Create an array of 10 numbers from 0 to 9. The first thing you do is, what do? You could just say NP. Okay, let me explain that before doing this. So, for example, you want to create a list or an array of 10 numbers from 0 to 9. We have np.arrange. You don't have to start writing a list 0, 1, 2, 3, 4. No, you can just call that arrange function. You just say np.arrange into brackets 0, 10. And this creates an array of 10 numbers between 0 to 9. So usually, if I don't have this function, I could have just said, let me create a list of 10 numbers 0 to 9, 0, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And then I haven't created this list, and I convert this list into an array. I'll just say np.array x. So this is what I would have done without this arrange function. I would have first of all created a list and then convert this list into array using np.array x. But instead of me doing this, you could just use your arrange function and just tell the function that I want 10 numbers. So my starting point is 0, and then my ending point is 9 plus 1, that's 10. So this number is exclusive. So if I want 0 to 9, I'll stop at 10. If I want 0 to 10, my last the stop position will be 11. So I believe you get that. So that's the function of the arrange. Arrange is used to create arrays with values in a specified range. All right. So you could also have steps in the arrange function. For example, you want to create more arrays with values from that with values with a particular interval, maybe an interval, even numbers or odd numbers, whichever the case is. So here you'd have to use your arrange function. Now, see the difference between the list and the arrange. Now, in this case, I would have just started writing from 1 to 200, and that's a lot of work. Why don't I have used the arrange function? np.arrange. Arrange is single arrow. Please, let's take note. I want numbers 1 to 200. So I'm going to stop at 201, right? And I want them to have an interval of 2. So I'm creating a range of odd numbers from 2 to from 1 to 201. So because we have, if I wanted 201 to be inclusive, right, I'll stop at 202. I don't know if you understand the concept of the stop, because if I stop at 201, right, it's going to pick it's going to stop at 199, because the last number 201 cannot be inclusive. It cannot be in that array. So because I want to stop at 201, have to put my stop at 202. So in this case, you can see that your arrange function easily creates an array of numbers with an interval of 2. You can see the numbers with an interval of 2, 1, 3, 5, 9, and all of that. And this is a one-dimensional array. If you want to check the dimension, you can just use the shape function. Let me assign this to y and ask y that y.shape. If I say y.shape, it tells me that this is a one-dimensional array. It has 100 row, 100 columns, and it's one-dimensional array. All right, so that's the arrange function. The arrange function helps you to create a range of values within a specified range. So you can create as many ranges as you like, different different intervals. Here you're creating a range of values between 1 and 51 with an interval of 5. So it's going to give you 1. The next number will be 6. 1 plus 5, 6. 6 plus 5, 11. 11 plus 5, 16. Up to 46 plus 5 will give you 51. But because 51 cannot be inclusive, and that's why you're stopping at 46. The end is always exclusive. I believe you understand this. Okay. Let me just test your understanding with arrange. Can you create on the okay, on the charts, generate a range of numbers between 3 and 15 with a step of 3. Generate a range of values between 3 and 15 with a step of 3. Can you do that quickly? Yes, you can calculate matrix with it. You're already working with matrices. I mean, matrices. Arrays are like matrices. A matrix is like a two-dimensional array. Okay. I need the code. I don't want the results. I'm going to try your different so I'm not going to tell you which one is right or wrong. So I'm picking the first. I'm picking Oluwa Dami Fola's I think he's the first person that wrote 3:16:3. So let me run it so that we can all see. Oops. Sorry, I was trying to copy and then it doesn't copy in well. Oh, it doesn't allow me to, it's not allowing me to copy. Okay, let me just type np.arrange. It said 3:16:3, 3:16 just 3. Is it correct? A range of values between 3 and 15 with a step of 3. Yes, it's correct. Absolutely. Thank you, everyone that said NP arrange 3:16:3. So I think we are getting it right. Okay, let's move to the next function. Is there any other? Okay, somebody said 0:15:3. Okay, so we want okay, let me try it. You know, in programming, there are several ways to get to the same answer. np.arrange 0:15:3. Okay, so the difference is we want a range of values between 3 and 15. So this is excluding, this is already including 0. We don't want 0. So that's why this would not work. All right. Okay, so let me see if there is any other okay, I think we are all getting it. Let's move to the next function. All right, 3. Okay, this gave 3:15:13. Okay, I was like doing an explanation for with another question. All right, so let us try the reshape function. Now, having understood the arrange function, the reshape function what it does is changes a scalar matrix to a vector. So if somebody was asking about matrices, so when you're dealing with arrays, you're already working with matrices, and we have scalar matrix, we have a vector matrix. So this is like a scalar, is one dimension. When you're talking about, for people that are beginners, don't worry about the scalar, the vector, and all of that. Just take it literally, like I'm explaining. Don't be confused about the naming conventions, right? They are good to know, right? But then don't let that get you like what's scalar, metric, and all of that. Just focus on the use cases, how they can be used, how can you implement and use this. So we have the reshape function. So what the reshape function is doing is that it's changing the dimension of a particular array into another dimension. You're reshaping it into another dimension. I'm going to show you what that means very quickly. Sorry, just trying to take a look at somebody. All right, let us continue. Okay, so given an array of a range of values between 0 and 9, this is a one-dimensional array, right? So you can easily, let me not focus on this first. Let me use the reshape function using this so that you understand better. Let me use A10. Now, this is a dimension, one-dimensional array. If I want to change it into like a two-dimensional array, like I want to divide it into 2 rows and 5 columns, right? I can use the reshape function. So what I just need to do is I'll call the name of the array, that is A10 dot reshape. I want to change it to 2 rows, 2 rows and 5 columns. So when I do this, it takes our array and divides it into 2. You can see that the dimension has changed. Now we can see we have a double square bracket. This is a list inside a bigger list. This is the first element in the list. This is the second element in the list, in the bigger list. And then we have the bigger list. So we can see that this is a 2-dimensional array now. Right, so the reshape function reshapes this particular array into different, it has flexibility. It's reshaping it into different sizes, but take note that the size has to correspond to the number of elements. Like here, we have 10 elements in this array. You can only reshape it to either a 2 by 5 or a 5 by 2. You can't do 1 by 4. It will throw an error because the element has to be equals to, the total number of elements has to be equals to 10. So I believe that you get that. All right. So I haven't noted that. You can also reshape it, just like I mentioned earlier. You can reshape it to a 5 by 2. That is, you're shaping it into 5 rows. 1, 2, 3, 4, 5, and 2 columns. So when we are doing panda, like people that are not so used to numbers might be very weary of arrays, but when we get to pandas, we'll be working more with CSV files, Excel documents, and tabular records. So maybe it might be more interactive, I mean, in terms of what we are used to. But for this, just try to understand some of these manipulations because they're also useful when it comes to some data science tasks, most especially if you be working with images and the rest. All right, so this reshape function, just take note that it reshapes it into 2 different dimensions. Like if you can decide to say, okay, what if, let me ask a question. We have a range of values. Sorry, hex equals to NP range, 15 x. Now this is how many elements. To find out the element, we could just do x dot shape. We have this 12 elements. So who can tell me what can we reshape this particular array to? What can we reshape it to? What are the sizes we can reshape it to based on the explanation? If you want to reshape this particular array, what can we reshape it to? Let me just give you the first. The first one is you can reshape it to a 2 by 6. So can we give other ways of reshaping this particular array in the charts? It has 12 elements. What are the other ways of reshaping this array? Okay, great. All right, great. We are all correct. We are correct. Okay, the shape column is in a column row format. So if you have a one-dimensional array, you find out that it does not include the row number. But for other dimensions, even the shape, if for example, you can check the shape of this now, you see that it's in a row, it's always in a row column format. This is one of the ones I reshaped, right? Y equals this. Y. Somebody's asking, why is this this one, when we are finding the shape of this one-dimensional array, why is it that the shape is in just a column row format, right? If I'm correct. Sorry. Right, and then when you're doing reshape is in a row column format. So when you're doing this, right, you find out that this would not include, it won't include the rows. It's going to just give you the number of columns. But when you have more than one dimension, like this now, if you do y dot shape, it's going to include the number of rows. So it's just telling you 2 rows and 6 columns. All right, so I believe you get that. Let us move quickly so that we can cover other ones. I think we all got that the reshape format. So let's move into zeros. Okay, so 3 would not work because we have okay, maybe UK, it was a mistake, right? You wanted to write 3 4. All right, okay. All right, okay, thank you everybody. So let's go to zeros. So NP dot zeros is used to create an array filled with zeros. So when you're working, sometimes when you're working with images, there are some parts that you might want to pad up with zeros, and it's always in RGB formats. There are some parts that you might want to pad up with zeros when you're doing your manipulation. Okay, there's one of the exercises. It's going to be a challenge. We'll be working on that. I want us to work on that on our own, because if we do that, it would help, it will help us to challenge us. So I want us to work on that on our own, but then I'll show you what you are supposed to do. So you're going to be converting, using arrays to convert some manipulations, and then you convert um, a an array of values, of different values. You're going to convert into an image so that you can see how these things work in practice. All right, so let us continue. Zeros is used to create an array filled with zeros. Sometimes you might want to create an array filled with zeros. You just, what the syntax is np.0, then the number of the number of elements that you want to create. If it's a one-dimensional array, you just put 3, 4, 5, 6, 7, 10, any number you want. It's going to create a one-dimensional array. But if you want to create a two-dimensional array, you give it the shape of that array. Now, you want to create a 2 by 3 array, like it's 2 rows and 3 columns. You can do 2, 3, np.0 2, 3. It gives you a 2 by 3 array. If you want to create a 10 by 3 array, the same thing, you can do np.0 10, 3. It gives you a 10 by 3 array. So that's just simply what zeros does. np.ones is used to create an array filled with ones. Just take notes: zeros, arrays filled with zeros; ones, arrays filled with ones. And it's still the same format that you're going to use, just like you have with your zeros. So the same way, np.ones, the shape, that is, you want just 6 elements, is creating an array filled with ones. Here you want 5 by 3 elements. It creates an array filled with 5 by 3 array filled with ones, as well as this 3 by 4 arrays filled with ones. There's also something called np.I. So for people that did linear algebra, you might be familiar with all of this, all these I, ones, zeros, identity matrix, and all of that. So np.I is like you are creating an identity matrix with NumPy. So without NumPy, all of this would have been very, very difficult, because you have to create several lists, write several functions or for loops to create all of this. But then with just some of this syntax, you can easily create your arrays. So np.I, the dimension of your matrix, as if it's 3 by 6, it creates a diagonal matrix. So what an identity matrix is that an identity matrix is a matrix with 1 on the diagonal. Across the diagonal, you could see 1 across the diagonal, and then every other parts are padded with 0. So here you have an identity matrix of 10 by 10, that is 10 rows and 10 columns. And if you want to manipulate your matrix, like you want to make it an identity matrix of 5, you can just say identity times 5, and then you see that it has calculated this, has done a calculation on this, and then you have 5 all at the center of this particular matrix. So that's part of the way to manipulate your matrix. So we also have np.full. np.full, what it does is that it creates an array filled with a particular number that you want. So take note, we have np.zeros, creating an array filled with zeros. np.ones, create an array filled with ones. np.what next? np.I creates an identity matrix that is 1 along the diagonal. np.full creates an array filled with a particular number. So this is the syntax. The shape that you want, np.full, the shape, comma, the number that you want it to be filled with, the specific number. If I want a 2 by 3 matrix filled with an array, filled with 5, 2 by 3 matrix filled with 5, you have np.full 2, 3, 5, and then it gives you this. If you want, maybe you want another, let me say np.full, you want a 5 by 5, 5, then it's going to be filled with 10. That is, you want a 5 by 5 matrix filled with 10. So you could just you give it the shape. That is, I want it to be 5 rows, 5 columns, comma, then filled with 10. That's what np.full does. All right. So you could have this as well. All right. So we have the linspace function. So the linspace function, what it does is it returns an evenly spaced number over a specified interval. How do I explain this? Okay, so there are times that you want a number. You have a number, for example, you have numbers between 1 to 5, right? Normally 1 to 5, counting 1, 2, 3, 4, 5. The interval is 1, right? 1, the next number is 2, 3, 4, 5. But there are times that you want a linearly spaced number over a specified interval. You want between 1 and 5, you want not just 5 numbers, maybe you want 6 numbers or 7 numbers. How do you do that calculation? It's more difficult. If you want 5 linearly spaced number, now if I want 5 linearly spaced number between 1 and 5, it's going to give me 1, 2, 3, 4, 5, right? Because the interval is 1. It's easy. But if I want 7 linearly spaced number, how do I do my calculation? This linspace function does the calculation for me. It gives me 7 numbers, right, that are linearly spaced between 1 and 5. So the interval between 1 and this is like 0.66667. Between this and another 0.667, another 0. So that is the interval. So that's what the linspace function does. It gives you a range of, it gives you an evenly spaced number over a specified interval. Do we understand? Do we understand the linspace? Okay. All right. Let us continue. So you can have different, you might want a linearly evenly spaced number over a specified interval. Like if you want 100 numbers between 0 and 10. If I just want 20 numbers between 1 and 20, right, that will just give me what? 1 to 20. So that's easy for me to calculate with my own head. But then if I want 50 numbers between 1 to 20, it's going to start doing there are some computations going on the ground that I might not really calculate immediately. So this linspace function is going to give me that linearly spaced number between that specified interval. I believe we understand the linspace. So the linspace function, also apart from giving me the number, right? You could also specify, okay, I've not mentioned, okay, I'm going to random now. I'm going to random. So let's go to random so that we can understand some other things. Random, what the random, I'm sure we are used to random numbers, right? Random numbers are numbers that are random. Let me use that word. And then it gives us any number within that are not actually defined, any random number. Let me just use it literally like that. So there's something called the rand. We have the rand, we have the rand n. I'll be telling you the different type of number. So the rand number creates an array. The rand np.random is from the random function. There's a inside the random function, there's another function called the rand. So what the rand number gives you random numbers between 0 and 1. And it can give you, if you want 100 random numbers between 0 and 1, you can use the rand function. That sets random numbers between 0 and 1, and it gives you all the computations with any random. For example, you want random numbers between 20 random numbers between 0 and 1. So you can see, if you check all of this, it's like a uniform distribution. Everything is between 0 and 1. The addition of everything, I mean, everything, you can't see any number greater than 1, and you can't see any number less than 0. So that's what the random does for you, right? You have the you can also define, this is just for 20 random numbers, right? You could also set that I want it in a 5 by 5 matrix. Aside it being this is just a one-dimensional array. If you want it in a 2-dimension, instead of giving it the total number of values, you could decide to give it the shape, and it gives you the random arrays into 5 by 5 matrix, and then you have np.random.rand 5,5. So you can see that all the numbers within here, they are not more than 1 and they are not less than 0. So for the rand n gets an array from a standard normal distribution, and it gives you all the numbers between in a normal distribution. In a standard normal distribution, you have the mean as what? Is it the mean as 1 and standard deviation as 0? Or the mean as 1 and standard deviation as 0? I'll confirm. For a standard normal distribution, it's always in a bell-shaped format. That's how a standard normal distribution is. When you say something is like a normal distribution, the mean, everything resolves in the middle. The mean is towards the middle. It has like an hunchback shape when you do your graph. Sorry for the people that are just beginners, but just follow through. If you're not understanding very well now, you get to understand what it is. By the time you start applying it to some use cases, then you can always, oh, okay, I can use a rand n for this this problem and all of that. Okay, so if you need an array from a standard normal distribution, use your rand n instead. And what it does is that it gives you all the numbers are between a standard normal distribution, and you can have a 4 by 4. You can have your shape inside. Okay, yeah, the standard deviation is 1 and the mean is 0. If you check, the standard deviation is 1, and then the mean is, let me check the mean. The mean is 0. So if you check the standard deviation of this particular matrix, you find out that the standard deviation is what? Is 1. That's the normal distribution. Standard deviation is 1 and the mean is 0. Okay, so we also have the random. I think this is one that everybody is used to. Like if you have a random number, and then, for example, they use it for all this I don't know, some of the algorithms behind this betting and all of that, but I know they do a lot of random things inside. So they might use some of this function in their algorithms, the random number. So if you want a random number within any range, right, you can use your rand int. You know, we've talked about the rand, we've talked about the rand n, and now we are talking about the rand int. So the rand int gives you random integers within any specified range of value. So the random.seed, this random.seed, what it's doing is that when you do a seed, it's like it seals your random. It's usually applied on random numbers. It seals your random number such that anybody, if I run a seed value on my system, it's going to give me the same random number as somebody. If you run the same value on your system, you have the same random number. So that's what the random.seed does. So it seeds this, it seals your random number such that if you want somebody else to generate the same random number that you have generated, you could just give the person, okay, use a seed of 78, and then you find out that we keep generating the same random number. So that's what the seed is for. So here, you want to generate the np.random.randint. You want to generate 9 random numbers between 1 and 0. And it gives you an array of nine random numbers between 1 and 0. If you take notes, if I keep running this seed, it will keep giving me the same value because I have a seed of 78 on it. You can see, but without the seed, now let me comment out the seed. Let me run this cell again. You see that I would always get different random numbers. Can you see the difference between having a seed and not having a seed? All right. So that's about the random numbers. I hope you're not overwhelmed with all of this, but let's just proceed. I think you get to understand better as we proceed. Okay, so now how can we apply some of these methods? We've looked at the arrange method, right? np.arrange, you can create a range of values between 1 and 23. It gives you 1 and 23. You can use the length to check the length of the array. If you want to create a random integer between 0 and 10, 10 random integers between 0 and 10, you can do rand int 0, 50, 10, and it gives you 10 random integer. Having this integer, you can decide to reshape them. You create, use reshape function to shape it to any shape you want, maybe 5, 2, 5. Using your reshape function, you can perform all of these manipulations using some of these functions easily. Once you have that at your fingertip, you can decide to say, I want to check the maximum, find the maximum value in this array using your .max function. If you do your .max, arl.max, it tells you that 24 is the maximum value. arl.min tells you that 0 is the minimum value at all. All right. You can also check the data type. It tells you the data type in this array is an integer. Okay. So that's it about the functions. Some of them. There are several other functions, but these are basics. So one thing you can also learn to do is, as you're learning, and that's why we so much encourage project-based learning in our boot camps and even in our learning our learning plan, our learning program, because we find out that most times when you apply what you're learning to solve problems, you get to learn so much more. We don't put out this, we don't rule out the place of you doing some in-depth advanced learning, and that's kudos to people that go for advanced degree, masters. We have people in our programs that have gone ahead for their masters and other PhD programs, and which they really, really excelled very well. So it's also good to use your skills as you're learning, you're solving problems, because that's the way to grow. get to grow a lot when you do that. And so we encourage solving problems. All right. So as you're solving problems, you come across some other functions that you've not learned in class, and you do a lot of research. Okay, how do you create this kind of array? And then you come across that function, and that is already in your knowledge bank. Okay, this is how I'm going to apply this function. And next time I come across another problem like this. Okay, I just thought to mention that we have like 9 more minutes before the open forum. So let me quickly run through indexing and selection. All right, so indexing, just like we have in lists, we did list indexing, we did indexing with dictionaries as well. For array, it's kind of similar, but you need to pay some more attention, because it might be, well, most especially when you're doing 3-dimensional selections, might be a little bit confusing, but just pay some more attention. You find out that it's very, very easy to do. So it's still the same way, zero-based indexing. So it's just for you to pay some more attention to it. All right. So given an array between 5 and 14, using your range function, you created an array. If you want to select, just like we do with our list, we want to select element number 8, what would be the value? That'll be 0, 1, 2, 3. That'll be ARR3. It also uses zero-based indexing, right? That's easy. We are used to that, right? If you want to select 14, you can say ARR -1 or ARR -1. We can use this, you can use minus your negative indexing or your positive indexing. This will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You could also say it's ARR 9, right? It's still 14. So either way is correct. Okay, so what if we have to reshape this? Okay, what if we want to do select? Can we select from 6 to 9? Let me do that selection from 6 to 9, then I'll give you another one to do. ARR, the first thing is 6 is allocation words, is allocation 1, full colon, just like we do with lists. That's the same thing you're going to do here too. This is 0, 1, 2, 3, 4. 9 is allocation what? 4. But because we want it's 4 plus 1, the last number is exclusive, so it has to be 5. Remember that if you want 6 to 9, this is allocation 4. You have to add 1 to the location so that it captures 9 as well. So, and that would give you 6 to 9. Now, can we index out 10 to 13? Can you give me the index number of 10 to 13? Index 10 to 13. Does number on the seed matter? No, it doesn't matter. It's just the number. The number is just, if you have the same seed as we're having the same seed, we get the same random number. Okay, 5, 9. Because of our time, let's just proceed. Let me run this. Okay, 10 to 13, great. So how did we get that? When you count from your left-hand side, 5 is 0, 6 is 1, 7 is 2, 8 is what? 3, 9 is what? 4, and 10 is what? 5. So because we want 10 to 13, so we're going to start from 5, then 6, 7, 8, 9. We are excluding 14. So because we one stop at 13, it has to be 8 plus 1. That's 9. I don't know if you understand. So it has to be 5 to 9. 5 to 9 is going to count 5, 6, 7, 8 plus 1, 9. So it's going to exclude the last value and give you 10 to 13. So thank you very much. You were correct. You're all correct. All right. So there are other ways of selecting. If you want to select everything in your array, remember our array is ARR. If you want to select all the elements, you can just do array full column. It returns all the elements in your array. If you want to select from, just like we do in list as well, it's the same thing. If you want to select from 11 to 14, you just need to know the location of this. You might not need to know the last number. Just say 0, 1, 2, 3, 4, 5, 6. That is 6 to the end, and it gives you 11 to 14. You might not have to include the last number. All right. So it's just the same way we do with leads. Now, before we go into the index, the indexing of the two-dimensional array, we're going to look at the ability of array to rebroadcast. So I'm going to explain that shortly. Given an array from 5 to 14, we can calculate the mean, right? That's the beauty about array. With a list, you cannot do that. You can just do ARR.mean, and then you calculate the mean of the array. It's going to tell you the mean of the array here. You can calculate the standard deviation of the array. All right. Okay. Having understood that, now let's create a random number from 1 to 10, between 1 and 20, 10 random numbers. And if you slice out this array, you can create a slice of the array. Like you can pick your first or your maybe you want to pick your first 5 values. That's 0 to 6, right? You can pick your first 5 values, and when you do that, you can save it into another array to create a slice of your array. So here, what you're doing here is that you want to select all the elements in this array, and you want to change everything to 99. So you can do that with an array, but with a list, you might not be able to do that. You want to update all the elements in here, and you want to change it into 99. So what you're doing is you're going to select this slice. You can either say slice of R, slice of R, can either say 0 to the end, which still gives you the same answer, or you can do this. It's still the same thing. So this, you're not saying, I want to equate it to 99. That's, I want everything to turn to 99. And when I do that, let me check my answer now. You can see that everything has been updated to 99. So you can do that with an array. All right. Okay, so but then when we go back to our original array, our original array, we took a slice. So what we did here was that we took from this ARL, we took a slice of 0 to 5, and we changed everything to 99. Now let's load our original array. You find out that everything has been updated now. If you load your original ARR, you find that everything has changed to 99 from 0 to 5. They have all changed to 99, and then you have your final value as what they have, what they were originally. So you can see that the changes also occur in the original array. As you're doing the slides and updating, the changes are also occurring in, the changes also occur in the original array. Okay. If you check the original, so to prevent some of this, you do copy. So most times when you're working with arrays, even when you get to pandas, you tend to like create a copy of your original array, so that in case you're doing any operation on your array and it changes the original format, when you create a copy, the copy is not affected. So if you want to create a copy of your array, what you do is you do the array.copy creates a copy of your array. So when you create a copy of your array, the copy is the same thing as the array. So whatever function you're performing on this array does not affect the copy. So if you need your original copy, you can still refer to your original copy if this one had been tampered with. Okay. All right. So that's being said, let's just look at the indexing of the 2D array, and then we can, do our quiz, and then we can take questions. So let me explain indexing of 2D arrays. Let's try to pay some attention here. So given this array, this 2D array, right? A 2D array is like a matrix. A matrix is like a 2D array. And you have, think of, like I mentioned earlier, think of this as what? The rows, and these as the what? The columns. So I think here I might have to use the whiteboard to explain some of these things. Let me see if I can. I think we have a whiteboard here. Let me check. Sorry, just I'm trying to get up the whiteboard so that I'll be able to explain better. I suddenly didn't see the whiteboard. I was always seeing it before now, but I can't see it here. All right, because of our time, I might not be able to do that because I don't want to start installing anything now because of our time. So let me just try to follow the cursor. Just try to follow the cursor, and you get what I'm explaining. All right. So this is a 2D array. This place is location 0. How do I do this? This is location 0. This is location 1. This is location what? 2. The same way for your column, the same way you have for your row. This is row 0. This is row 0, row 0. This is row 1, and this is what? Row 2. So take notes. This is column 1, column 0, column 1, and column 2. Now, for example, you want to index out the first row. That is this one, the first row. You just do ARR1 and it gets you out the first row. That is this one, sorry. If you want to index out the first row, that's row 0. 5, 10, 15, it gives you row 0. This first row. If you want to index out the second row, you use ARR1, it gives you the second row. If you want to index out the third row, ARR2, it gives you what? The third row. But what if you want to index out the first row and the first column? How do you do that? So the first thing is to take up the first row, that is 0. And then the first column is what? The first column is what? 0. Okay, this will index out the first element, the first row and the first column. The first row. This is the first row and the first column element. That is 0, 0. It's going to index out 0, 0. But if you want to index, if you want the first row and the second column, the whole of the column, you do something like this, and it gives you the first row and the first row. It gives you the first row. Sorry, I'm mixing it up together. This should be full, and then this is 0. It's either way. Okay, so we have the first row. This is still giving us the first row. So I told you this thing could be very, very confusing if care is not taken. So let's go over it again so that we don't get confused. To index out the first row, right? You do ARR0, and then you index out the first row. To index out the second row, you do ARR1. To index out the third row, you do ARR2. That understood, right? Now, let's do the elements, each individual elements first before we go into the bigger ones. The individual elements, if you want to index out the first row and the first column, so that the first row is what in location 0, and then the first column is also in location 0, and that would give you 5. If you want to index out the first row and the second column, the first row is in location what? 0, and the second row is in location what? 1. So it should give you 10 now. All right. If you want to index out the first row and location, the first row, that is at location 0, and the third column, that'll be 0 and 2. All right. That'll give you 15. Now you want to index out 20 now. So what will happen? So this is now 20 is in what? Location what? Row what? Row 1. So this will change to 1. And then is in row 1, column what? 0. Column 0. And that will give you 20. I don't know if you're following this. Let me check the comment. I don't have the comment open, so I can't easily navigate to know if you have questions. All right. If you have questions, please let me know so that I can take them. All right, let's continue. Okay, so we just indexed out the second row and the first column. If you want to index out the second row and the second column, what would it be? That will be still on row 1, column what's 1. That's 25. Now, I believe we understand the individual single elements index. Now, let's go into 2 elements. If you want to index out the first row, right? That's what? 0. And the first and the second element, that's 5 and 10. We want to index out 5 and 10. Now, this is what we want to index out. 5 and 10 is what in row what? 0. But then they have column 0 and 1. So it's going to be 0, 2, just like you're indexing out 0 to 2. So that would give you 5 and 10. I don't know if you understand this indexing. Okay, so if you want to get out 25 and 30, for example, the first thing to take note is 25 and 30 belong to what row? It belongs to row 2. I mean, row, that's row 2. That is at location. What's location 1? This is row 2 at location 1. So the row location number would be what? 1, comma. 25 and 30 is as our what column? This is what column 0, column 1, and 2. So you can just say 1 to the end. We don't need the last digits. You can just say 1 to the end, and that gives us 25 and 30. Do you understand this indexing? What if you want to index out just 10, 25, and 40? Now, 10, 25, and 40 belongs to what? All of the rows. 10, 25, and 40 belongs to all of the rows. So I'm going to put all of these rows, comma. Then at what column do we have 10, 25, and 30? That is our column what? 0, 1. That's column 1. And then you have 10, 25, and 40. I don't know if you understand this. Okay, let me find out. Can we index out 40 and 35? 40 and 35. Are we still here? If I had the whiteboard, I would have maybe explicitly shared it on the whiteboard. 40 and can we try? 40 and 45. So 1 to the end, okay. Okay, thank you. Yeah, that's correct. Let me share. I mean, let me run it so that we can all say, okay, I'm seeing another one. 2, 1. Okay, you might not need this extra square brackets. So what Damifola said was 2, 1 to the end. So 40 and 45. So this is where, and then let me try the other one. I'd not tried that before. Let's see if it works. Okay, so it's saying invalid syntax. So you don't need the extra square brackets. I think this is just enough. This would work. So what is happening here is 40 and 45 is, first of all, identify the row. It belongs to row what? Row 2. That is, this is 0, 1, 2. This is row 2. And then because we want just 40 and 45, we don't want 35. 40 and 45 belongs to what column? This is column 0. Column 1, it starts at column 1, 1 to the end. That's why you have the 1 to the end after the comma. So do we understand that? You want us to take one more example? All right. If we don't have any other questions, I think we'll just go into the open forum. We've taken too much, we've eaten so much into our time. What if you want to change a particular number in the row? Say this. I want to change 4 in row 2 to 7. 4 in row 2 to 7. I'm trying to understand the question. Like, okay, you're talking about updating the if you can index, you can update. Once you index it out, once you can get the index, you can easily update your what you want to what you want to update, so long as you can index out that element. So if you want to change a particular number in the row, you want to change 4 in row 2 to 7. So just get the index and equate it to 7, and it updates, or do the updates for you. Okay. So if you run ARLD 1, what will show up? I'm trying to get that explanation or question rather. 1 to the end, 1. Okay, so if you run 1 to the end and 1, this is what will show up. You're just indexing out 25 and 40. That's what you're indexing out. That's your indexing out. You're saying you want to for the rows, I just want this row 1 and 2. I mean, row location 1 and 2, and then at column comma, then at column 1. So that's why you're having 25 and 40. Do we get the indexing? All right. Do we have any questions? Do we have questions? Okay, for the Python exercise, we go to the classroom. under June 2nd, we have the recordings, and then so we have the exercises attached. So please try your hands on those exercises, and then there's a place where you can submit your assignments. Just try your hands on it and submit your. So there are three questions. There are three assignments that you're supposed to work on and submit. Yeah, just try your hands on it and submit. That's what I was explaining the other time. So for today, there is one assignment I would want you to try your hands on. It's going to help you if you're able to, get it done. Let me check this question on NumPy. Yeah. So I'm sure we know how to do this. Import NumPy as NP, right? Create an array of 10 zeros. I explained to you in class. Create an array of 10 ones. Create an array of 10 fives. You know how to manipulate that. You create an array of 10 ones are multiplied by 5. Create an array of integers from 10. So before you do your assignment, ensure you create a cell so that, because once you run the cell, you've erased the answer. So you create a new cell and do this np dot ones. All right, so I need to run np first. Import. All right, so you create an array of 10 fives. So you first create an array of ones, but because you want fives, right? Try not to run this cell so that you don't erase your answer, so that you get to the answer. Then you can say multiply by 5. Sorry. You can see that np.ones multiplied by 5. That's the answer. So once you're able to work your answer to this, then you know that you're on the right track. Create an array of integers from 10 to 50. You should be able to create that, right? Create an array of all even integers from 10 to 50. So this should be your answer. Just try to work towards all of these answers. Create a 3x3 matrix with values ranging from 0 to 8. So you first of all create a range of values from 0 to 9, then reshape it. Create a range. So there are some of these questions that you might have to use 2 functions, 3 functions to generate your answer. Just ensure that you create enough cells to do your calculations before you finally run it, so that you don't erase the answer. All right, so I hope you get that. So this question on NumPy is here as well. I can also link it on this class recordings. It's here. You can access it here. NumPy assignment. Yeah, NumPy assignment. This is it. So you can download it from here, or I'll link it on the other hand. All right. So do you have any other questions? No, don't stop. Do you have any other questions? Okay, for lambda, yes. Because sometimes we intentionally give some of the questions so that you can do some little research. Little research. So try to the truth is it's not all everything that we can mention in class because of our time frame. There's so many other things to, because there are a lot of things to cover. So you might not be able to mention everything in class. All right. So, but then you can do some research, check online, find out about Lambda out. But Lambda is very, very easy to use. Just find about Lambda, and then you get that. That's the essence of you. When you submit your question, your assignment, we look through it to check what your idea, the way at which you're able to apply your knowledge to solving problems. All right. Okay, so do we have any other questions? Do you have any other questions? Okay, if there are no questions, okay, sorry, I missed one question. Random dot choice. Okay, it randomly selects a particular value from a list of values. So just check, you can check up what random dot choice does. It returns a randomly selected element from a specified sequence. So the sequence can be it can be a string, can be a range. It randomly selects elements, some randomly selected elements from a specified sequence. That's what random dot choice is. All right. For the installation, what particular problem are you having with the installation? What error is it showing? Is it that I don't know, do you have a particular error message? Okay, let me just unmute so that, our time is fast spent. We are 3 minutes behind schedule. Okay, so we are typically done for what we have for today. Thank you all so much for your time. I hope you're able to learn one or two things. Just try as much as possible to try your hands on some of these hands-on exercises. They would further strengthen your knowledge, and you can go through the recordings as well. All right, and just keep learning. Don't be discouraged. I know at some point you might be wondering that, why am I learning this and all of, but then the truth is, for you to know, to get into data science, there are some basic things that you have to learn that are very, very important. So, and they'll be needed in your journey as a data scientist. So it's good you learn all of those things. All right. Okay, so if you don't have any question, you can drop off. Let me just take one or two things, a question from the persons that needed clarification with NumPy installations. All right. Okay, so I just unmuted you. Umar, you can just raise your hand so that I can see. I can be able to unmute you. I'm trying to look for your name here. Okay. All right, I just unmuted you. Please, you can talk.
Evening. Thank you for this wonderful presentation. I have been download this Anaconda Navigator since some months ago. So
Okay.
all the package Anaconda, there's no any NumPy this thing.
Okay, you installed the Anaconda
Yes,
successfully. Can you run your Jupyter notebook? Were you able to load
I
the
can run
Jupyter
Jupyter.
notebook?
Yes, I can run PyCharm.
Okay. So did you try installing NumPy?
No, I didn't.
Okay.
So
Okay. Okay. So go ahead, please.
I just want to is there any link that I should download the NumPy, or everything is there in my Anaconda navigator? I'll just
Okay.
download it through Anaconda.
First of all, try to go to your Jupyter notebook and run import NumPy. Try to import NumPy as NP on your Jupyter notebook. When you import it, and if it throws an error that NumPy module cannot be found or something, then you need to install it. And to install it, you would need to run your, let me see if I can share my entire screen. You need to run your, you have to run your your Anaconda navigator.
Okay.
Can you, I mean, sorry, Anaconda prompts. Can you run Anaconda prompt on your local directory? I mean, on your system?
Yes.
Can you open
Yes.
Anaconda
Yes.
prompts? So when you open
Yes. I can
Anaconda
run.
prompts, then pip install NumPy.
Okay.
When you pip install NumPy, it will install NumPy for you.
Okay, man. Thank you.
Yeah, so that's basically
Another
okay.
another question regarding to our first assignment. I find it very
Okay.
difficult to upload a picture, which is the last question. I copied the directory of the part of the image. I paste it there, but it failed to display the image. So I don't know if there is any
Okay, which one is that? Is it the
missing.
Streamlit application?
No, the first assignment.
Okay. I'm trying to understand the one that you're talking about. Which of the assignments? Is it the Python crash course exercise 2?
Yes, the pattern crash course exercise. That one.
Which particular one are you having issues with?
The one that you say we should upload picture, any picture of our choice.
Oh, okay, that's the Jupyter notebook exercise.
Yes, yes.
Okay. Okay, so you said you have issues where?
When I have issue when to this upload the picture.
Okay, you can go through the recording of the first class. There towards the beginning, well, I took you through how to use the Jupyter notebook and how to how to upload pictures using into your Jupyter notebook. So if you go through that recording, you see how to solve that problem.
Okay, ma, thank you.
All right. Okay, thank you so much, everyone. Do we have any other question before we close? All right. If we don't have any other questions, thank you all so much for joining today. Do have a wonderful evening. We meet again on Wednesday by 8 o'clock. And yeah, try your hands on the NumPy exercises too, and let's see how we're able to perform with that. We'll do our quiz on Friday. I mean on Wednesday. We could not do our quiz because of time today. We'll do our quiz on Wednesday. All right. Enjoy the rest of your evening. Yeah, bye.